Okay. So we were talking about the steric effect, that is bulkiness of the group. See, you can see here, we have written cis-2-butene and trans-2-butene. These two compounds, they are geometric isomers. They are geometric isomers. And you know what are geometric isomers? They have different structures due to the inability to rotate around the double bonds. Due to inability to rotate around about a double bond. You cannot rotate around a double bond. You can rotate around a single bond, like you know. You can rotate a molecule around a single bond and you will get two different conformations, but rotation around a double bond is not allowed. So you get when the CH3 here and CH3 here, this is different from when the CH3s are on the same side. So one is cis and the other is trans. So this is, and you can see the properties of these two compounds are very different. Okay, the polarity of this molecule is toward, this bond is towards this direction. This bond is towards this direction. So there is no net polarity. So net polarity is 0. Net polarity is 0. But here, the polarity is on one side, it is this direction, and on this side, it is this direction. So overall, there is a polarity towards this direction. The average of these two will be along this direction. So here to here. That means this side will be delta negative, and this side will be delta positive. So that is how you can think of it. Okay, and that means there is a net polarity is there. So polarity, net polarity greater than 0. Okay, that is usually, so that is the effect of steric effect. Similarly, you can see, we have seen the steric effect, the effect of how the steric effect will affect conformation. How will steric effect affect conformation of molecule? Let me remind you, I have told you many times, conformation means is different directionality or spatial arrangement in the same molecule. Spatial arrangement in the same molecule. Same molecule. They are not two different compounds. Look at butane. Look at simple butane molecule. See here. This is a butane molecule. Let me draw the butane. CH3, CH2, CH2, CH3. Now, if you look along the C2, this is 1, this is 2, this is 3, this is 4. If you look at the molecule along the C2, C3 axis, if you observe along the C2, C3 axis. Okay, that means you have C2 here. I will draw the two carbon atoms. This is C2, this is C3. And then I have three bonds here. This is C1, C3, C4, C4, C3, C2, and C1. Now, remember, I can put one bond here and the other bond here, H and H. And here also I can put my H over here and H over. Okay, so this is one way of drawing it. I can draw the same thing in a different way. I will put this here and my CS3, yeah, I'll put the CS3. And my hydrogen over here. Okay. So this is butane molecule. Two forms of butane molecule. How did I get this one? I have got from here, I can get this one simply by rotating around this bond. Just by 120 degree, I have to rotate. Rotate 120 degree clockwise. Around this bond, you keep this stationary and rotate these three bonds, CH3 here and CH3 here. Rotate different carbon only. If you rotate by 120 degree, this carbon will reach here, and these two hydrogen will go to the other side. So one of the hydrogen will be front, the other will be back. Now you can see here, if you observe these two molecules from here, observe these two molecules from here, how will they look like? How will they look like? And that is what is called Newman projection. So this is wedge dotted line structure, dashed line structure. Okay, and the one which we are going to draw, when we observe from here, you look from this side and see how it looks like. See, your eyes are here. Okay, that projection, and you can think it this way. You are keeping a screen here. This is a screen. It's a screen, white screen, white. Now you pass torchlight on here, torchlight. Switch on a torchlight, a torch center. Pass a light onto the molecule from this side, only one side. Okay, and imagine the shade which is falling on this screen. The shade. You draw the shade of the object, which you are going to see here. Okay, so you are looking from here. You are going to draw the shade. And you can see the two hydrogens are. When you look from here, the two hydrogens are up, and this methyl is down. This methyl is up, and these two hydrogens are down. Okay, so you can see here there are two hydrogens, one methyl up. And here also you have two hydrogens and one methyl as well down. So that is how you are going to do. Now, how will this bond appear when you look from here? Think about it. How will this bond, this hydrogen, which is coming to the front appear when you are looking from here? You can see that it is bent to the right side, and the hydrogen on the back side is bent to the left side. And what about the methyl group? The methyl group is down. These are the three. Now observe this. Now what I'm putting here is a circle. What is the circle? What does the circle signify? It signifies there is the front carbon. It is signifying the front carbon. Okay? It is signifying the front carbon. And back side, the back carbon. Which is the back carbon? This is the back carbon. This one. This carbon is behind this carbon. You cannot see that. Now if you're looking from here, how will this CH3 look like? How will this CH3 look like? The CH3 is on the top that we have written here. The CH3. It is here. How will the CH3 look like? It will be exactly vertical up because you are looking from along this line. So this CH3 will look exactly up. And what about these two hydrogens? One hydrogen is on your right and the other hydrogen on your left. So this is what is called a Newman projection. This way of drawing. This way of drawing is known as Newman projection. Okay, so this way of drawing is known as Newman projection. And see here, look at this writing. You can see the bulky CH3 groups are far away from each other. The bulky CH3 groups are far away from each other, and you can if you think about an angle, this angle. Look at this angle. It is approximately 120, 180 degrees. This angle is 180. Okay, the angle between the two CH3 groups is 180, and that is what is called a dihedral angle. Dihedral angle. We are going to study this again. Dihedral angle equal to 180. So you have two CH3 groups are maximum away from each other. Two CH3 groups are as away as possible. As away as possible. But what about this one? See, two CH3s are on the same side. So which groups are on the lower side? You have two groups on lower side. 4 hydrogen up and 2 methyl down. Okay, and now observe what about the hydrogens? The 4 hydrogens, are they vertically up or are they bent? Think about it. You can see here, if you're looking from here on the upper side, let me take it out, take it down. Yeah, you're looking from here. This is projecting towards you. This hydrogen is projecting towards you. These two hydrogen is projecting away from you if you're looking from here. Now suppose you are looking from this side. If you are looking from this side, you can see the CH3s are vertically down. The two CH3s are one behind the other. Okay, two CH3s are one behind the other, one of them is out to the center, and two hydrogens are on the right hand side. On different carbon, you have two more hydrogens. And that carbon also, one is behind the other. Okay, so this is this molecule look like. Now look here. You have both the CH3 groups on the same side. Both the CH3 groups are very close to each other. And the angle between these two CH3 is 0. The angle between these two CH3 groups, they're overlapping one above the other. So dihedral angle is 0. Dihedral angle is 0. At that point, you have two CH groups which are very close to each other. What is the consequence? This is a stable conformation, highly stable conformation. And this one is highly unstable. Unstable conformation. Okay, and this is it's called eclipse conformation. So the molecule will not prefer to exist in this form. The molecule will not prefer to exist in this form. It will always prefer to be away from each other. Okay, so this is stabler than this form. Stable, unstable. This is because of the interaction between the bulky groups here. Due to interaction between these two CH3 groups. So that is the effect, the steric effect on the conformation of a molecule. Example of steric effect on the conformation of molecule. Okay, similarly you have reactivity. We can consider the reactivity of compounds in steric effect. How does steric effect affect the reactivity? Steric effect affect reactivity. Okay, I'll give an example of a chemical reaction in which, give an example, if you take this compound, you must be knowing this compound. Okay, this compound is COOH. COOH. If you react this with water, you will have an equilibrium. The equilibrium is C6H5 COO minus plus H plus or H3O plus. I will write H3O plus. That is And for this benzoic acid, the pKa value is 5.05 pKa. You must be knowing what is pKa. I don't want to explain that again. Okay, so the pKa value is 5.05. Now look at this molecule. See this one. Let me put two bulky groups here. COOH. I'll put a T-butyl group here. Okay, I'll put. So this is 2,6-di-T-butyl benzoic acid. 2,6-di-T-butyl benzoic acid. Benzoic acid. See, look at equilibrium. Same equilibrium. Think about the acidity. Remember, these are observed facts. These are observed facts, experimentally proven. It's experimentally proven. So I got COO minus plus H3O plus. See here. Now, what is important is pK value. pK value. The pK value of this compound, what do you expect? What do you expect? The pK value of this compound is 6.25. pK value is 6.25. What does it indicate? Which is more acidic? Which is more acidic? Which is more acidic? Okay, what is the relationship between pK and acidity? As we increase the pK, the acidity decreases. Inversely proportional. pKa is inversely proportional to acidity. If you increase the pKa, the acid is less acidic. So which is more acidic here? So benzoic acid is more acidic. More acidic. Benzoic acid is more acidic. Now what is the reason here? See, the water is not able to approach here and catch it out, take it out. Because of the bulky H here, I have 3H here, H here, and also you have H here, and H. Similarly, you have hydrogen here. Okay, so these bulky groups will prevent the entry of water to capture this, will hinder, these bulky groups will hinder the ability of the water to take away this proton. Okay, so this is due to steric effect. Similarly, I will give you another example, very similar example. If you take this compound, if you take CO, okay, benzoic acid, either benzoate, ethyl, benzoate, and treat with sodium hydroxide. Treat with sodium hydroxide. Okay. An ester reaction with sodium hydroxide, aqueous solution of sodium hydroxide. Ester it forms, get hydrolyzed into this sodium salt of the acid. COO minus Na plus PDOH plus BDOH. Now let me put two bulky groups here. Let's put two bulky groups here. One is here. Here is COO-BT. Okay. So two bulky groups. One T-butyl group here, one T-butyl group here. Now, if you react this with sodium hydroxide in aqueous medium, react this with sodium hydroxide in aqueous medium, in water, that's the meaning of aqueous medium, you will get nothing. You will not get anything. Oh, sorry. Let me cancel this. No problem. No problem. Why? Same reason. Same reason. The two bulky groups will prevent the entry of sodium hydroxide and breaking this bond. It will prevent the bulky T-butyl groups. Prevent the CS3 groups. Sorry, not CS3 groups, OH group. OH group to approach the the COO. So it cannot, this attack is not possible. But here it is quite feasible. Okay, so this is in fact two examples of steric effects. Okay. Similarly, we have so many other examples, which also I will write a few of them in case you are asked to explain. A third example is esterification reaction, the reverse of what we have done. Okay, what is esterification reaction? Esterification. Esterification rate is affected by the steric. That is, if you increase the number of, this is esterification. Suppose you want to convert this into the ester, what you have to do is ethyl alcohol. You take C2H5, sorry, I'll write C2H5OH. It's not a fair way of doing it. I will write C2H5OH. Okay, in sulfuric acid. Remember, sulfuric acid is a catalyst for this reaction. H2SO4. catalyst. I'll write catalyst here. And now this will give you CH3, CO, C2H5, C2H5 plus the molecule of water is getting coming out. Now, if you replace this hydrogen with a methyl group, you'll get ethyl. You replace different groups. Each hydrogen you replace and find the rate of reaction. It is found that CH3COOH is faster in reactivity. Reactivity order. The reactivity order is in this one. CH3, CH2, COOH. What did I do? I removed one hydrogen and kept one ethyl group. Still greater rate of reaction if I put two CH3 groups to CHCOOH. Still faster if I have three CH3 groups. CCOOH. That means if you increase the number of methyl groups here, the rate of reaction decreases. So this is the reactivity order. Okay, so I will write increase in reactivity. Increase in the esterification. Esterification. Okay, so that is similarly benzoic acid, which I have already described, very similar to this one. So this is in fact what is steric effect. So I'll give you another example. CH3, COO, two methyl groups. If I take this one, look at the same esterification if I have COOH, CH3, CH3, C2H5OH, C2H5OH, H2SO4. No reaction. No reaction. We cannot convert this into an ester by this method. Okay. You have to use something else. This C2H5OH cannot come and attach here. Okay, you may have to convert this OH group into something else and then do some other reaction, type of reaction. So this method will not work because of the hindrance. So steric effect is affecting the reactivity. So this is these are the different effects. Okay, and the stability of carbonium ion, carbanion, and free radicals are affected by resonance effect, inductive effect, hyperconjugation, and steric effect. Okay, so this in fact briefly describes the first chapter. This is very briefly what we have to cover in the first chapter, the reactivity, the different reaction intermediates. Okay, so what you can do is just go through the exercises in the textbook. Some of you will be, if anybody is having a textbook, you can just take the exercise and work out a few problems based on this. Okay, naming and all these things are there. You can just go through that and write the answers and find out. Okay, so we will continue tomorrow with the second chapter. Thank you.